Okay,
Every morning.
how's everyone?
Okay, how are you?
Not bad. Tired, ready for bed.
Yeah, I think it's just Monday.
Of course, Monday. Okay, so let's talk shop. So we know that there's the extra credit going on
With the group that's gonna throw everyone out of the water? Yes.
yes.
Our group, this class. Oh, wow. I'm dressing up.
So we have TSS de los Muertos. I have to confirm, but I believe that they want us to set up on Monday. I will confirm that, not today, next Monday. I thought it was
Halloween?
today.
31st?
Yes.
That's what I was thinking.
Yeah, because otherwise it's gonna be sitting over the weekend, and I don't think anybody's gonna watch it. Was that? Yeah. Well, not only that, things disappear and come on campus and sabotage.
Do we have class?
Yes, you do. Halloween is not an official holiday, especially since you guys. What was that? Halloween?
Some
No.
people it's not.
No, vacation.
No, never. Usually,
Not even weekend. Thanksgiving, Christmas, Thanksgiving. or New Year's. I'm sorry.
okay. You know those are. Yeah. Okay. Okay, so let's talk. We have a month, less than a month left, because you guys actually finished early. You guys finished in November, right? November. Your class officially ends November 18th, the week before Thanksgiving. 18th or 19th or something.
So we're done like 2
That's a Wednesday or Friday?
What's that?
Is that the Wednesday or the Friday?
It is, you guys are done. Technically, you're done on the Friday, but Wednesday is the last day. So you'll have a final to take on Wednesday. Okay. A class.
Everything. Yeah, I'll try that.
And
That's all I can ask.
Yeah, as well as other classes.
So it's really
I
crunch.
brought my laptop. I carried it all over here. I brought the damn truck.
So
It's dead.
normally I would not have you guys come in if it was Halloween, but since we're like really fresh and we're really behind, so we have to come in. So I will see you guys, I'll see you guys today, and I'll see you guys on next Monday.
Okay.
So if we're efficient, we'll be able to get a lot of it knocked out of the way, okay?
Okay.
So that means that you guys have to come in ready. Next week, we'll be going over chapters 10. Today, we'll be finishing chapter 7 and chapters 9, okay? So 7 and 9 is what is the goal today, and then chapter 10 on.
And then our test unlocked today.
Your test should have already unlocked, should have locked this morning. But there was some issues with active learning over the weekend. So check, they just came back on board today. So your practice tests. Oh, you guys, yours is not an active learning. You don't have to worry about that. So
Our practice test is
yeah,
on
it's on
the
Canvas.
canvas.
Yes, it's already unlocked. It was unlocked yesterday. So your test is unlocked. The practice test is already unlocked. You can do them as many times as you like. I only have it set for 40. If you get to 40, let me know. I still want to keep going. Okay. And you guys have already been assigned to groups for your group project.
Yeah, but we haven't been assigned the project.
You guys have been assigned the project.
You're lying.
A rap song?
Yeah. So
But no,
let's
wait, you
talk
gave
about
us that, but you didn't give us the subject.
I did give you a subject. It's in your group. Let me give you your group.
Oh, no.
It's on Canvas, isn't it?
Yes, it is on Canvas.
It says what?
Yes. Okay, let's see.
Like a disco.
The blue team. Pretty Ricky. Let's see, Sarah,
I'm happy that it takes that.
Sonia, Jack, Oro, and Gabriel. So you guys have gas law and your genre is pump.
This is for. Rapping?
I thought we were gonna be able to choose our genres.
No, I think you're genre.
I thought you were in my group too. They changed it.
Okay.
Because my group started with Jack, Sarah, April.
Yeah, I moved some things around because there were students that had dropped until we had. Okay, so the green team is, they have nomenclature and it's disco. And that's Felicity, that's Juan, that's Brooke, that's Kalisa. Kalissa,
Oh, volleyball.
James, and Rihanna. Juan's right there.
What's right there? What does right there mean?
Juan, wave your hand.
In the burgundy hoodie, that's what I said.
Oh, I thought you said.
Making sure. At least I guessed right.
Okay, the orange team. The orange team is Michael, Jose, Itzel, Arlette, Leanna, Valerie. No,
Oh, you got country?
you guys have country.
I don't like
And
history.
Which country?
it is electron configuration.
Just play some random guitar in the background. There you go.
The pink team has dimensional analysis, and you guys have nursery rhymes / sing along. So that is Edwin, that is Butters, Adelaide, Janet, Janet, and Alyssa. And then the other ones are anybody not called?
We're all wearing sunglasses and hoodies on this thing.
Anybody not called? Okay, so those are your topics, and those are your genres. You guys have nursery rhyme / sing along. You know, like merrily we roll along. You know, something like that. And then it'll be fun.
So we actually have to sing it?
Yes.
Where did he have on it?
Excellent. He asked, the question was, how long does the song have to be? So the song has to be 2.5 to 3 minutes long.
And is it gonna be
So not even your
is it gonna be
employees.
one clip with all of us,
Right.
or is it gonna be like we do our own clip of like?
That's up to you guys. That's how you guys decide. But everybody has to at least sing the hook, you know? So everybody has to participate.
Dr. Andy,
Yes.
is it gonna be recorded and then played in class or
Yes,
performed in
it's
class?
a video. No, it's not a performance.
It's not a
video.
performance?
Yeah, it's a video. You're making a video. You're gonna record the video, you're gonna make a video, it needs to be edited, and then I need you guys to upload it so I can have access to it ever.
Not even your employees.
If we upload it to YouTube, can we get extra credit?
What was that?
If we upload it to YouTube, can we get extra credit?
Yes,
Isn't there like a project part that you do in class, like presenting with your?
yes,
class?
it's 3 parts, okay? So let me open up the
The whole effect.
whole assignment
So when does this have to be done?
tomorrow.
No.
The end of the semester. So your presentation will be that Monday, that last week of class. It'll be that Monday for the last week of class. Your final will be that Wednesday. Okay,
Okay, so we're doing it. Okay, cool.
All the details are.
I think it's you have like 7 people. You have like
every last.
Where is it? Where, no, what's it?
Yes,
I have 5 other people besides me.
yes.
Shut the fuck up, you're stupid.
Like 3 people.
It doesn't make her plural.
You have to rethink the question. I'll give you a minute to rethink the question.
You know, if you're looking for.
Oh, yeah.
Okay.
Yeah.
You guys have
We
a
see like
nice
an
email.
example of it, like, see like, so I got
The video?
of like the whole shebang.
I can give you an example of the whole shebang. Yes, I will provide that. I'll get that for you for on Wednesday. I do have a.
Yeah, some people are good with visuals.
Do a video?
Because we
I
have
do
to
have
write down, we have to create our own
Yeah.
lyrics, our own music.
No. Okay, so, you know, it's a parody. So a parody is, do you guys know what a parody is?
Yes.
Yeah.
Okay, so it's a parody. So you find a song that's very popular, right? And you erase all those lyrics and you write your own lyrics with that particular topic. Let me give you an example.
We've seen those.
Now, what was that?
We've seen those.
That's good. I'm glad you guys have seen this. Now you're gonna do them.
Is your genre rap?
That's tough.
It's just go.
What's take me
Huh?
home?
I wouldn't even
That
know.
would be a good song, right?
I feel like country's the easiest one.
Is punk like
Country
those?
isn't good, I don't like country, and I go country.
Which
Either.
country?
It seems like the
Yeah,
easiest one to do
exactly.
though.
I like to give you guys challenges. You need to
Because it
work
doesn't
out
need to
what
be
you're
fast, it
used
could just be like kind of like hip
to.
slow
Y'all have been
pace.
to comments.
Country.
I'm breaking at comments. Yes, I'm showing you an example.
Let's see, punk music from the 2000s, see what pops up. Oh, do you know what My Chemical Romance is? I didn't know that was punk. Teenagers, Coalinga, Famous Last Words.
That's like the,
I'm not too sure.
it's like the one.
You need to get that camera off me, sir. This is not my good angle. I'm a selfie angle person. I'm a selfie angle person today. I'm a catfish. I'm a catfish. I catfish myself. I didn't even realize how fat I go.
Energy's ability to work or transfer heat. There's different types of energy that aren't so discrete. Kinetic potential, and every object has substantial potential to exert energy. In this song, you will see. Kinetic energy is the energy of an object in motion. I'm just gonna have an motion or subthermic motion. Heat can transfer from surface to surface, moves over equal subsurface. Heat can cause objects to melt. All these states is what we got. F times mass times velocity squared. Easy math, no need to be scared. Motion constantly going over like an odyssey, and it can be stored in the bonds don't beyond. The joules become sub not backing up the combustion of organics to kinetics. Potential energy is an easy concept. We won't lose it. Propane, methane, and also butane are potential organic compounds. Keep that in your brain. Now let's go insane.
Joule we use to measure energy. This is the song of the century. Joule named after James Pascal Joule. Look at him, he was no fool. Energy is all around us, thus we can study it, see what we'll discuss. Stick with us, you can trust. Chem with Dr. Henry is a must.
Kinetic energy is the energy of an object in motion. I'm just gonna have endothermic promotion.
Energy is going to be motion. Energy is clear like an iron motion.
Kinetic energy is the energy of an object in motion. I'm just gonna have endothermic promotion or exothermic demotion. Heat can transfer from surface to surface. It moves over even a subsurface. Heat can cause an object to melt. All these states is what we got. F times mass times velocity squared. Easy math, no need to be scared. Motion constantly going over like an odyssey.
No, sorry.
Welcome back.
See, 2.5.
This has rap.
How did you know the full song was 7
Cause
minutes?
I know the actual song intro, so maybe.
Just like that, I know what it said.
I don't feel
Someone else
educated at
will
all. What did they even say?
It's rap, you don't need to.
Okay, so that's an example, right?
Okay.
Okay, so I'll give you guys an example of the page itself. So I'll have to pull it up because it's in an archive. So,
Okay. Does that mean in a desk or something?
yeah, in a disk or something, exactly.
See, I've been a fire. So,
Okay. So does that help?
it terrifies us.
Yeah.
Just
Why? I thought that was great, you
You
know?
can't even understand what they're saying.
I know that's about.
The only part I heard was Connecticut.
Yeah.
It was me.
You also have to take in consideration that we don't have the best unified audio. It sounded a lot better when it was played from the system that we're at. Because their system went down. Everything went down. I thought it was fun, especially considering if you knew them individually, each of them, this is definitely not the genre that they would pick. Could you tell?
a little bit.
Yeah.
But it looked more like.
One of them was.
It says on your group.
Okay. So last week we were talking about molecular
My sister.
and formula mass. You guys remember that?
I don't know what they were.
Yeah. We did talk about molecular formula mass. We talked about molar mass, right?
Yes.
We talked about the mole.
Which one?
Chapter 7. I gave you guys the sangria recipe.
Yes, you did. But it's not payday yet, so it's still pending.
Okay. So we reached
I really have to drink that in class.
okay. So we take a look at this, right? So we know that we're given units. You have this many units. You have this many atoms. You have this many molecules. You have this many Ys. You have this many. We can convert that to moles by using what? I said, if we're given that we have this many atoms, this many molecules, or this many Ys, we can convert that to moles by using what? Avocado's constant. That's right. Okay, and what is avocado's constant?
And eight.
No, that's the symbol. What is the
Oh.
numerical value of the constant? Okay, 6.022 times 10 to the 20. Okay, so if I'm given grams, how can I convert grams into moles? There you go. Don't look away. You start looking away. Arlette? Juan said he'll help you out, right, Juan? What do you use? Nope. Not molecular mass. Say it again. There we go, molar mass. That is correct. Now, what is the difference between molecular mass and molar mass? Wait, that might be a question on the exam. Slow down. Okay, and what do you mean by the molecule? said specifically what it's
Coalinga.
covalent. There we go. Formula mass. What is the difference between formula mass and molar mass? Bless you. Formula mass. Ionic, okay. And then molar mass. Is it just covalent? Not molecular mass. Molar mass. Molar mass. Okay, and what can I use it with? Nope. What is the significance of using a molar in the first place? Why do I need to use it? Did you use the unit 12? No, you're, I know what you're trying to say, but think about 212. Say it again. Say it louder. Carbon 12, right? It was based upon carbon 12. That's true, right? So, but what is the significance of using molar compared to molecular or formula?
I'm thinking, I just saw it for.
No, I said, what is the significance of using molar instead of molecular?
It's with the each 12 carbons, right? And then molecular.
No, because we know that carbon 12, you're making reference to carbon 12. Carbon 12 is an isotope, right? The isotope carbon 12, it's based upon carbon 12. They counted all of the molecules of carbon 12, right? So, and carbon 12 weighs how many? How much? How much does carbon 12 weigh? How much? 12. That's right. It weighs 12. Carbon 12. It weighs 12, right? Now, the question is, when we're talking about molar mass, what are the units?
Grams,
Grams per what?
grams per mole.
Grams per mole.
It's the
So,
mass.
yeah, it's grams per mole. So what is the significance of it being in grams per mole instead of AMU? Atomic mass units. How many of you guys sit around playing with one atom each day?
Are you referring to our phones?
No, I'm not. I am not referring to your phones.
You're talking about one atom.
One atom. Do you play with one atom each day? No. Right? Get your mind out of the gutter there, Jack. Not atom, atom. Get your mind out of the gutter there. Jack likes to play with atoms.
Oh. All love here.
So now we know that when we talk about the mole, right, we're making reference to a lot. So much that we can actually handle, that we can deal with, that we can play with, right? Not just one atom, right? We have to play with a mole, right? Okay? Like the animal, the mole, right? Okay, so we know that if we're given grams, we can use the molar mass to calculate the quantity into moles. So grams, so if we have grams, we use the molar mass to get to the mole. Okay, mole is like our gateway drug. That's where we want to get. We want to get to the mole, right? Because we know that if we look at the chemical equations, you guys know how to balance chemical equations, right? You can do it like your eyes closed and your foot up, and you know, you can do a drinking game. Have you guys played what was it? Where they put the keg on second base? Slosh ball. Right, you guys ever play slosh ball? Okay, well, when you guys get old enough, and you get, bored with life, you can play slosh ball, right? But the beer can on second base, kind of like slosh ball, but you guys can play it with doing chemical equations, right? So you run around the hit table, you spin around, and you look at the answer, somebody take a chemical equation, you're able to balance it on problems, right? But we know that that's based upon the chemical equation is based upon what? Is it based upon mass, grams? I don't shrug. Is it based upon grams? Do we say I have 6 grams of this plus 2 grams of this plus yields 5 grams of that? Right? Is that what it can say? No. It's based upon quantity, or we can say moles, or we could say molecules or atoms, right? But we know that it's based upon quantity, right? Since it's based upon quantity, we needed to get it to quantity so we can figure things out, right? We talked about those recipes, didn't we? Talk about recipes?
Yeah.
Yeah.
Cake?
Give it to us.
No.
I don't know about alcohol.
Oh, we talked about sangria. Right? Okay, so did we do this problem?
So what?
So let's start with this problem. Determine the mass in grams, 3.2 times 10 to the 24th molecules of sulfur tetrafluoride. Okay. So what is the first thing that I should do? First thing, number 1. What is the chemical formula, right? That's what you tell me. Tell me, what is the chemical formula of sulfur tetrafluoride? S something, and that's a good start. Now we get our sulfur, so we got the S. It would be 4. What was that? S what?
F4.
Oh, you said F4. Is that what you said?
No, I said 4.
Okay, so because we know that it's sulfur tetrafluoride, right? Oh,
Tetrafluoride.
Penta. Penta is fine. Okay, so we know that we are working with SF4. Okay, the next thing is that we're given that there's 3.2 times 10 to the 24th molecules. That's a SF4. Okay, we're given molecules. What am I going to use to get to moles? The constant, Avogadro's constant. And we know that Avogadro's constant is 6.022 times 10 to the and we're putting them on the bottom because we want to get rid of molecules and we want moles. But do we stop there? What are we trying to get to? We're trying to get to grams. So if we're trying to get to grams, how do I get to grams? What can I use? How can I go for moles? Because right now, the units that we have left are moles. How do I go from moles to grams? Okay,
The weight of the molecules.
the weight of the molecules. So we have how many sulfurs in sulfur? We have 1. And we have how many fluorides? We have 4. Okay. So we know sulfur weighs how much? Okay. And fluoride weighs that's fine. 19 times 4. That's
Or 4.
that's 79.995.
75.
So let's just say 76. 76 grams per mole. Okay. What was that? We said plus the sulfur? Oh, we haven't added the sulfur. So 108. Okay, so I want grams. Do I want grams on top or do I want grams on bottom? That's right, I want it on the top. Okay, moles are going to cancel out. And we're left with
But then that's what she's very-
black. We got 2 sig figs.
So it would be 5.7 to
Or you could say 570. That's 2 sig figs. Because you want 2 significant figures, right here, 2 sig figs. That's 570. So instead of saying 573.8957157, right? We just want 2 significant figures, so we take a look at that 3. So 3 is less than 5, so we round up. I mean, below, so that it's 570. Okay. Sorry. Everybody got it down? Ready to move forward? Oops. Did you not get it down? You got it down? Okay, so the next thing we want to talk about is called percent composition by mass. So percent composition by mass is just the part over the whole. Okay? Now, what do I mean by that? So if we have a compound, we're looking at one of the elements of that compound, or we could be looking at a ion, like a cation, or just the anion of a compound. So in this case, if we have calcium fluoride, so what is the percent of fluorine in calcium fluoride? Well, in this context, we're going to use the molar mass because they're not giving us any work, right? And we know that ideally it should work out always the same because by the law of definite proportions, we know that it should be the same regardless of how much we have, the ratio, its mass ratio to the composition of it. Okay. So the way we do this is we know that fluorine weighs how much? Well, first off, what is the chemical formula for calcium fluoride? CaF. 3, 4, 5, 6, 7, 8. What is the charge on calcium? 2, that's right, plus 2. Okay, so then that means how many fluorines do I need to? So it should be CaF2. Okay, so we know that calcium weighs one calcium. Okay, and then we know that fluorine weighs 2 times 19. Okay, so then we'll add that together. Milligrams per mole. So we have 2 fluorines and calcium, so then we know that that was 38 divided by 78 times, and then that would give us our percent calcium. Sorry, percent fluorine, not calcium. So can we calculate our percent calcium? So we say 100 minus 48.7. Okay, piece of cake.
Is that 51?
Yeah. 100 minus 48. So we just take the mark. Yes.
Where did we get 38 from?
38 because 19 times 2.
Oh,
Because it's the amount of fluorine, right? So, and then divided by the total. So it's the part divided by the whole. Does that make sense? It's 70.
No, we're like,
What are you talking about?
38 over 70.
Okay, do you see that? Yeah, yeah. Yeah. Okay, so calculate the percent composition by mass of aluminum sulfur. And they basically want you to calculate them all. The aluminum, sulfur, and whatever else is inside. So first thing that I want to do is to do what? Mass of what? We need the formula. So what is the formula? Yeah, formula first. Al. Al. SO, or -2 charge. Okay, so then how many am I going to need to balance out? What's the charge on it? You said what? The charge on aluminum is what? It's +3. That's right. It is a +3 charge. We cross multiply, so that means that we have 2 aluminum, and then we'll have 3 sulfates. -2. Where can I find it out? Ion table. Okay, so what's the next thing I want to do? Mass. Okay, so I'm aluminum slab. Aluminum weighs 2 times 27.1.
But that's just not enough. 26.98.
Okay, so then S, how many S's do I have? I have 3 S's. Because remember, the 4 is next to the oxygen. Okay? It's 32. And then we have oxygen still. 12. 12 times 16. This one is 154. This one is 96. So we have those all together. So then if we're trying to calculate our percent aluminum, how would I do that? 54 divided by the grand total. Because it's the part over the whole, so we're just looking for the part that's aluminum times 100. Okay, so then if we want the sulfur, percent sulfur would be (96) over what? Now you want to take the whole, right? Because it's a part. Yeah, it's part over the whole. Because we're looking at the percentage of sulfur in our compound. So it's always going to be part over the whole. Okay. What? Or we could have just said 100 minus 1. Minus 15. Questions? Any questions? No questions? Okay. Well, we're looking at 100%. We're saying that there's 100%, everything adds up to 100%. Right? So then you're subtracting from 100%. Does that make sense?
I mean, it should.
So the question was, so what, it was kind of like, why are we subtracting from 100%? Or why are we subtracting from the biggest? Well, the biggest is always going to be 100. You're assuming that you, the best you can get is 100, right? That's good, some crazy stuff. But it's probably not chemistry, you know, right? So in the case that we get 100%, then we're going to subtract the others, and then the remaining should be what's left over. So the oxygen is going to be that 56.1 is because that's what's remaining. Okay. Now let's flip it up a little bit. Aluminum chlorate is 38.3% chloride. What mass of aluminum chlorate is needed as a source of 50.0 milligrams of chloride? How would I set this? Okay. Is it just ClO? ClO3. Then how many of those am I going to need to balance it out? Okay. So, what is the question asking? What did it already provide? It gives us how many we have of each. What does it give us? There's two things that it's giving us. It gave us the amount of chloride. So we have 50.0 milligrams of chloride. Right? So chloride. So then we have X amount of our aluminum chlorate. And then what else do they give us? They gave us the percentage chloride, so we know it equals 35. Chloride. So then we just solve for X, right? So we multiply both sides by X. Okay, so then that's gonna cancel out. And then we divide both sides by. 138. $50.0. 38.35. That's in milligrams. Okay. Seven, 8. So how many sig figs should we have? So we have 3 here. We have 4 here. Are you sure? Right?
Yeah.
So then we write it as 1.30. But the rule is least number of figures. Okay, you guys ready? The next one. That says 1.30 times 10 to the. I think it says X mg. Yeah, because you multiply both sides by the same thing. We're trying to get X by itself. Okay. Questions? No questions? Okay. 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 The next thing we're going to be talking about is empirical formula. Okay, so we make reference to the empirical formula. The empirical formula is basically the lowest integral ratio. So the lowest whole number ratio that we can get comparing each of the elements of the compound. So let me give you an example. So if I have CH4, C4 H10, the empirical formula for that would be C2. Okay, so it's basically the lowest term that we could have in our subscripts. We divide them both by 2. That makes sense. Okay. So if I have C6 H12 O6, what's that mean? Said 363. So you want to divide it by the largest number that you can divide everything by. So what can I divide them all by? By 6. So it's CH2. So if I have C2 Cl6 F2. What would be the empirical formula? Okay. Questions? Questions? What's that? Empirical formula. I said, here was the other example. Got it? Okay, good, because all you want to know is the empirical formula. So the definition of the empirical formula is basically getting it down to the lowest terms that we can get. Okay. Okay, so the way that we calculated this is that we find that number that we can divide everything by. Try to get the smallest ratio, whole number ratio that we can get. Okay. So now when we're doing this in terms of a compound and they're giving us grams, the first thing that we want to do, since we know those values, those whole numbers that we're talking about in our subscripts, we know that they make reference to quantity. So we need to get it into terms of quantity. So here's an example. A pure substance, a sample of a pure compound is made up of 1.61 grams of phosphorus and 2.98 grams of fluorine. Find the empirical formula of the compound. Okay. So the way that we start this off is that we have 1.61 grams phosphorus. We need to convert that to moles. How would I convert that to moles? What was that? Okay. So 31 point what? So 31. 31 grams per 1 mole. So then we do the same thing for chlorine. What is the mass of chlorine? Then we figure out which one is the lowest value. And we're going to divide both numbers by that lowest value. Which one is the lowest? What's value? So then we divide both of them by that. P. Okay, so here we're gonna round it to the nearest whole number, or try to get it to the nearest. So in this case, since it's 3.0, that's really close. So if it's anywhere from 3.1 or 3.08 or anything like that, you can round it just to 3. So we're just gonna round this to 3. You know that this is just 1, right? So we have for every 1 phosphorus, we have 3 chlorides. So our empirical formula is going to be P, F, that is a very good question. Give somebody some answer. Okay, so if it's 3.5, so what number could we multiply both numbers by so that it would give me a close to a whole number? It's 0.5. So yeah, said 3.5. Right? What can I multiply 3.5 to give me a by 2? If I multiply this by 2, that would give me 7. And then I'd also have to multiply that P by 2 as well. So then it would be let me give it to you. So, oops, sorry. So if I have 0.2, if I have a value of 0.2, what can I multiply 0.2 by to get a whole number? If I have 0.33, what can I multiply 0.33? If I have 0.25, what can I multiply by 0.25 to go? So 0.5 is 2. And then if I have 0.66, what can I multiply 0.66 by? Sorry, 3. 2/3. If you multiply by 3, yeah, it gets you close to.
Oh,
So because it's 0.66666666. I didn't want to put the 666.
yeah.
So 0.75. 0.75.
There's two.
All numbers. So what can I multiply by? Because right now it's 3/4. So if I multiply by 4. Right. And then 0.8. Okay. Okay, do you guys see the table right there? Right, so anywhere from 0.2 to 0.8. So if it's 0.1, you can go ahead and use that. Round. If it's 0.2, that's what they have to multiply by. Does that make sense? If it's 0.99, everybody got it down?
Dr. Henry, was all that you just said typed?
Okay, so when we're given percent, that's percent mass. So in this example, we have nicotine is 74.1% carbon. It's 8.63% hydrogen, and it's 17.3% nitrogen. What is its empirical formula? So it's percent mass. So if we assume that we have 100 grams of nicotine, how much of it is going to be carbon? 74.1, right? So we're going to make the assumption that we have 100 grams. So we have 74.1. So let's first assume substance. How much of it is going to be hydrogen? 0.64 grams of hydrogen. And how much is going to be nitrogen? Okay, so since it's grams, we need to change it to what? Moles. So what is the molar mass of carbon? 12. So 6.175. Then for the hydrogen, what is the mass of hydrogen? Okay, and nitrogen. Nitrogen is what? So 120, what? Okay, what number is smallest? Okay, so divide everything by the smallest number. Five, 7. Okay, questions? Concerns? Okay. Great. Okay, so if we're given, or if we have to calculate, the only way that we can calculate the molecular formula is if we're given the molar mass, and we have the molar mass to compare to. So let me give you an example. It says a compound with the empirical formula C2H5 has a molar mass of 58.12. Find the molecular formula of this compound. So in this case, if we're given the empirical formula, or we have to calculate the empirical formula, we can use that to calculate the empirical mass. Okay. So, and then we'll divide it by the molar mass of the actual molecule. So we know that we have C2H5. How many carbons do we have? So 2 times 12. And then we have how many hydrogens? One. Grams per mole. So that would be our empirical mass. Okay. Then we'll take the molar mass of our compound. And divide it by the empirical mass. And then this will give us the number that we need to multiply our empirical formula to get the formula, or the molecular formula. So we multiply everything by 2. So that would be our molecular formula. A lot of times they'll give you a range of a molecular formula, or a molecular formula falls within this range. Then you need to figure out what you want. Okay. Questions? Concerns? Cash? Kool-Aid? Credit? Okay, let's take a 15-minute break. Stretch your legs. Rest your eyes. Take a shot of that espresso.
Shut us up.
Happy birthday. Have some. So be back in
21.
21, so let's be back at 36. Okay, so let's see. I want us to practice a little bit because you guys have an exam, right? And it's covering this stuff is the bless you. Bless you. The main squeeze. So, let's see those skills.
What did you call?
Yep, we're gonna go to action.
There's the thing, it's hot.
And
I was like, I'm just thirsty.
we put it together.
I want to drink it. And that's what-
Okay, did everybody get a chapter 11 and a chapter?
Helen.
Yeah.
Yeah, he just handed them out when you were gone. That's right in front of you. Should have right in front of you. Is it under your periodic table or is it on your notebook?
Right here, right here.
I'll drink these on Halloween. Sorry, Halloween. I'm gonna dress up like a Gucci. Yeah. No, I did like a little side job on Saturday. It was for the beer crawl in Clovis. When I tell you, I saw the hoochiest in my life. Oh my God, I'm inspired. I'm inspired. They're the cutest costumes. Like, there's no Asians here. All the Asians had like the sluttiest costumes. They were so cute. They look like the anime characters. Yeah, and there was this one guy dressed up as a little kid from Up. He had balloons and everything in the sash. It looks adorable. Russell. There was people dressed as Pac-Man. They had like the cardboard cutouts on them.
Listen, I'm Mexican. Yeah, I know. I was gonna say Joseph Johnson. It's like I count, right?
What?
You said there's no Asians here. But I'm like,
I know, I got cheeky eyes, so it counts.
This is mega. Works. Sure.
Anyways, I made $80 at that job, so I get that check on Friday. I'm like, I might go get a costume probably. I'm fine.
Some people who live in-
Okay,
So-
what?
so-
What are you? You're gonna have so much fun.
I was like.
But don't stick with your group. Fuck those people. Don't listen.
Okay, and then you're right. Okay, if you're going to the business, you're going to prison, right? These like 7, you
No.
got 10.
No.
Oh, no, we didn't get the 2 camp passes. So we have to get that.
Okay.
Yeah, stay till like 2. It's fun. It's worth it. From 7 to 10, you're not gonna be able to get through everything you want to see. You guys get fast passes? The weekend, that maze was 2 hours long. I don't know. You might be able to. My brother-in-law was being negative. So what is the weekend? Scary. But that was his favorite maze when we left there.
Oh, I think Sam does as well. Or-
Okay, if you guys go to active learning.
Okay. Okay, if I go on my phone because my laptop died.
Yeah,
Where am I charger?
You got it working in your phone?
Huh?
You got it working in your phone?
My brother-in-law was helping. You knew all of them off the top of your head. My boyfriend got it. I was like, what the fuck? You nerd. I didn't know you knew this stuff. But all of a sudden, dying over here. The mole and prickle formula one?
Yep. Question of an unknown compound containing only carbon and hydrogen produces.
C2H3.
Thank you. I just got the text.
Yeah, see, it says the 5th, right? For this year.
It says the second.
Okay, there's a typo because I seen another one. This one was just closer. There's another one. It says the 5th on it. Could be the 5 p.m. though. It was dark.
Okay, so now this one is a little different than what we do, but than what we've done. So in this case, all of the carbon is going into the carbon dioxide, and all of the hydrogen is going into the water. So we're going to use that to sit there and work our way back. Okay. So if we have 12.3 grams of carbon dioxide. If I want to change carbon dioxide, grams of carbon dioxide into moles of carbon dioxide, how would I go about doing that? Yeah, but how do I? Just leave 12, but carbon dioxide. Carbon and carbon dioxide the same. So we have to first get carbon dioxide. So how do I find the molar mass of carbon dioxide? How many carbons are in carbon dioxide? One, and then you say we have 2 oxygens. 16 times 2. That's 32. Avogadro's number is 6.022 times 10 to the 23rd. So okay, so we have 44 grams on the bottom, 1 mole on top. That's of carbon dioxide. Now we have moles of carbon dioxide. We want to get moles of carbon. So the way that we go about getting the number of moles of carbon, we look at how many moles of carbon if we have 1 mole of carbon dioxide. So what is the ratio? How many carbons are in carbon dioxide? Oh, is there 12? Oh, not weight, but so 1, right? So for every 1 mole of carbon dioxide, I have 1 mole of carbon. That's how I get my carbon. Okay. And so I'm going to do the same thing for hydrogen that I did here. Yeah, we'd round up. That's low. So I'm going to have 3.8 grams of water. What is the molar mass of water? 18. It's 18 grams for 1 mole. Okay, what is the mole ratio of, for every 1 mole of water, how many moles of H do we have? We have 2.
Does it make it-
Okay, so we end up with 0.42. So what are we going to divide by? Zero. Five. 1.5 hydrogen. So what do I have to do? Carbon will be 2. Two carbons. Yeah. Hydrogens. Okay, so that's C2. H2. Just the same question you asked me earlier, right? You don't remember, Jackson? And this is the type of questions that I like to put on for the short answer. That's we know the ones that stay around for the party. Everybody got it down? So yeah. Yeah, racing. What is the percent mass of both in C3H8O2?
Wait,
76.
so do you have that?
Yeah, we can do it. Sure. I deleted SpongeBob off my phone.
It's okay.
I would like to go much.
Piece of cake.
Which is my one with your calculator, but that was supposed to be this. Oh, duh, it's 0.6.
Okay, so if 5.9 times 10 to the 25th molecules of carbon dioxide are produced in a combustion reaction, what is the mass in kilograms of carbon dioxide? So if I have molecules, how do I get to moles? Avocado's number. What is avocado's number? So I need 6.022 times 10 third.
That was 25. Why is it 23? Oh, never mind. Oh, it's avocado.
It's going to be one more. But we want mass. So 97.97. Okay, what else do I need to do to get to mass though? Okay, so I have moles, right? So my units are moles. So how do I get to moles in that sense?
Yes.
1 mole of CO2 is equal to what? What is the molar mass of carbon dioxide? 44, right? So we got 1 mole of CO2, 44 grams on top. Yeah, so we need to get kilograms, right? We got 44 grams because we know that carbon weighs 12, and oxygen, and there's 2 of them. Oxygen weighs 16, 16 times 2 is 32, plus 12 is 44. And 8,000 grams. Four point 3.1. 268.
So tired. No, no, no. See them too late.
Okay, everybody got that answer?
I'm working on typing them all prior to the calculator.
No.
I do
I'm
the
trying to do that,
one- Oh, never mind, it's not right. Multiply one at a time.
I did it all.
Answer 25 times. No, wait. When you write the times.
So what is the mass in grams? 36.70 moles.
Delete. Put down one.
Gas in grams. How do I get from moles to grams?
Everything we just did backwards.
What is the molar mass of gas and bromine? So that-
Oh, sorry, I forgot. Got it.
Start with this one.
Yeah, we found the right spot.
That's not the right spot.
I got it to go down.
One you got to find there.
Actually, 120 grams.
Okay, so let me show you. So Then second.
I don't even take this part.
You don't have to put this in. One time. You can type it all in.
Soil.
You don't take
Okay, what
it.
did you guys get?
Oh. The first two options are in the road.
Yeah.
Oh, how did I do on the calculator? Do you want to write it down?
Okay, so the empirical formula of a compound that contains only iron and oxygen, and it's 27.6% oxygen.
Number 3. You did that one. I was still finishing this one. You told me how to write it. I wasn't sure. I was trying to type in the whole part. You don't need to.
Got the wrong answer?
What is it? 7 grams.
So we're gonna make the assumption that we have 100 grams of our compound. So that means 47.6 grams of it is oxygen. And then how much of it is iron? We have if we're assuming that we have 100 grams of our substance total, how much of it is going to be? So that's 72.4. So then what am I going to do? I have grams divided by its mass. Okay, so oxygen, the mass of oxygen. So that's 16. Okay. One 73. Okay, and then iron. What is the mass of iron? 6 point something.
It's 55.84, so it's just 55.6, right?
55.6.
What did you round it?
Oh, no, wait, 4,
What is the number?
4, so shit. Might just be
55.876.
845.
845.
So since it's a 4, you don't round it up, right? It's the same?
So 55.845.
Yeah.
We're just being difficult. I'm being.
You need a nap.
I do need that power nap. 2 presentations.
Are you a procrastinator too?
No, I just had things that were higher on my priority list. Okay.
I love that.
Give you guys a few more minutes. I'll give you a few more minutes.
That's the way.
We got a prepaid phone.
You're inspired. You'd like to invite me.
And don't be afraid.
We're still at his house.
We feel like clowns. Unless you like clowns. Oh,
Movie?
build a maze. Wow.
Okay.
Alright. Alright.
Okay.
It's just the rest of us. Those 4, 3, 6, 7. Connection just put 3.
44.
61. Still work.
44.
This work. This work. Correct answer was 4, 3, 6, 1. No, 4, 6, 7. That was it. That's the answer.
Yeah, I got it right.
So they give us a ton of leeway.
Is that?
They give us a ton of leeway. Should put 4, 4, 4.
Because it depends on how you. They give you some. Okay, what did you guys get?
The last one.
Last one.
FE.
04. Sure.
Well, of course.
Yeah, I'll take one of those, but.
Bible classes like this one.
And then I have 2 more that just started their online.
So much better.
So you guys got, I got 1.7 2.
moles for moles
Sorry, I
for.
was thinking. When I looked up like this. Half of it.
7.3. Approximately. Then you got
Right.
1.30 moles for ice. So we divided both of them by this one by 3. And then divide this one by 1.3. And this is going to equal 1.33. So if we multiply this by 3, half by 3. I'm sorry. What's that? I might just press that one. Oh, no submission. Okay.
That is not.
There's something inside.
Okay, questions? Concerns? Cash? Go to payday.
As
Okay, chapter 9. Start it. We're not gonna finish it. We'll go for another 15 minutes and then I'll let you guys out.
Chapter 9?
We're chapter 9.
Okay.
So you have to actively participate. in what you are doing.
Yeah.
Burrito waiting for you?
Yes. Hungry.
Okay.
Where's the number 9? Let's walk back. Be free to grab our hand.
Okay. So in chemistry, you often will have to try to figure out if things conduct electricity. One way of doing this is by using the light bulb conductivity apparatus. So basically, you take a look at this. We have a nice little light bulb, and for electrodes are what your electrons are flowing through. The electrodes are connected, then the electrons are able to flow through it continuously, and so then you're able to get light. So if I hit my switch, that opens the electrodes. So then electricity isn't able to flow through it, and we get dark. In this case, my electrodes are connecting, so we're able to get flow. So we have these electrodes. When they're not connecting, there's no flow of electricity. When they're connecting, there's a flow of electricity. So if I put a piece of metal through there, touching both ends, what's going to happen? Touch the piece of metal. But if I put a piece of metal on this end, that are connecting these two, we're going to get conductivity and we're going to get electricity, right? We're going to get light. Let there be light.
I'm just kidding. When we're all young. Also, right now, it's got the dog in it. Spider. Spider.
I need to try to make those. I have a recipe for it. I haven't tried it. I don't like paying for it though, because the chicken tenders are small. I like the sauce.
Like some people like.
Okay.
You get an electric fence.
Yeah, I'm trying to. Yes, I am. That's been my plan the whole time. Just gonna fry it now. Okay. So. That's the method. If you want this, we're gonna add it to the current. Okay, wait, right now, no light, right? Now, I put these together. Can you guys see over there? If I put these together, I get light, let there be light. Right? Alligator clips come together, I have light. Everybody sees that. See light? Everybody see light, okay? So, I have aluminum metal. I see light, right?
Yes.
That's fancy, right? That's it. I see light. Okay, that makes sense because we know that metal conducts electricity. So I have plastic. You see light? No light, right? Okay, now that makes sense, right? We expect that to happen. Anybody got an apple?
There's people right there.
Oh, excellent. Let me see you. What was that? Guava? This is guava.
Right in front of us.
Oh,
Okay. Do I see light?
yes.
Okay. Why?
Is it like the potato thing?
Acid, yes. It is like the potato thing. Yes, it is sort of like the potato thing. Because we have acids, right? We know that an acid is just
But doesn't it fit one of these?
don't the potatoes taste.
No, don't the fit ones. These, for a specific one.
Okay. So we know that we have citric acid. Yeah,
Costs $5 by December. So you can buy one. Maybe, unless I sign another form. Maybe, I don't really like them right now. Because my brothers use my room for to have a whole year. Sticking out. Or smoke. Not true, but maybe, I don't know if there's like. I mean, I don't know. His last girlfriend went crazy, because then he had 2 kids. And she went crazy.
Pick their parents, they can pick their parents.
Actually left them with their family.
Inspired.
Yeah,
That you were with today. Inspired. Inspired.
yeah.
So this is citric acid.
Oh, you gotta, told you.
So context, what happens is that when the acid is in solution, and if you guys looked at it, it wasn't like glaring like the metal, was it? No. So the thing that we know about citric acid is a carbon acid, carbon-based acid, and carbon, right? So carbon-based acids have the ability to dissociate, but they don't dissociate completely. So what happens is that you have them going back to when they're connected together. And then we have H plus H6.
Movie?
You should just have to test this. We have it the same thing.
That's actually also the one.
So both of these events exist. We have the separated ions, the H plus and this hydrogen. And then you have the one where they're together. Okay. This one is favored. You have a lot more of this compared to these. So, but since you have those ions are acting to help conduct electricity, so much what we saw with the metal. Not to the same extent because they're not completely dissolved. So you see how bright that metal is, right? We put the metal there. Compared to when I stick it in the fruit. Right? Right? Nowhere near as bright, right?
Or listen.
Definitely not like this. Okay, you guys see? Okay. So thing is that what we're going to be talking about is called ionization. That's separation, right? Weak acids don't like to separate very well. Strong acids do. Okay, and you want to keep that in mind. So here we see a solution, right? So if we have water, totally pure distilled water. I like to use our water, but our water is typically not pure and distilled water, right? It's totally distilled, there's no ions in it. There shouldn't be any electricity conducted, right? Because it is a non-electrolyte. So if we use ethanol, ethanol would be a non-electrolyte. So if we have electrolytes like Gatorade, anybody drinks Gatorade? Right. So if we have electrolytes, or if we have this Monster, Monster has a lot of supposedly vitamins and everything in it as well, right?
Yes,
Is it true?
it's organic.
You said it's organic?
Mhm.
Monster is organic? If you lose the loose definition of organic, meaning that it has carbon, yes, Monster is organic. But okay.
You'll get it later.
Favorite. Okay. Now compare that to the fruit earlier. So is this brighter or was the fruit brighter? Right. Okay. So here we have a lot more electrolytes. that are available for us to use. So if we take a look, we have strong electrolytes, so stuff like, in this case, we have copper chloride. Chloride and the copper are separate. Copper chloride. They're separated from each other because they're soluble in solution. In the case of acetic acid or citric acid, we have a weak acid. Some of them are separating. So you have a few that will separate, but the majority of them are still separated. Okay, so that's what we're seeing, the difference between this guy and the fruit and the monster. What the hell was I drinking? Bless you. Okay, so electrolytes. Electrolytes is just the passage of electron charges through a solution. Okay, so things that are charged, so are ions. So it has to ionize. So the concept of ionize, breaking up into the ions. So when we put things in water, a lot of things ionize. What happens when you put salt in water? It dissolves, right? And so what really happens is that it ionizes. We get that plus charge and that minus charge. Water is kind of like that home record that says, this is salt here. This represents salt. He's the positive, she's the negative.
Wouldn't salt be the home wrecker since it's on an inch?
No. Because water, you have water, all water.
Okay.
So straight solution. Just let me tell my story. You just listen. Listen to my story here. Okay, they represent salt, right?
Okay.
Right here. This is salt.
Okay.
So water comes up to it. Hey, baby. I got you. I'll take care of you. I'll treat you real good, right? Okay. Soon as she turns her back and she's like, oh, water, water, right? Hey, baby, you don't need her. I got you. I'll take care of you, right? So water basically surrounds the book. Because if you think about water, water is bipolar. Word over here.
Okay.
Polar.
Yeah, I guess that. Yes. The word I do think is like, yeah.
So we know that water, H2O, is sharing electrons. Now, the way it's sharing electrons is uneven. Okay, so it's sharing unevenly. The majority of the electrons are being around oxygen. They spend more time around oxygen than they spend around the hydrogen. So because of that, we get a polar formation. So this guy would be partially negative. This here means partial. It means not completely negative, but there's a lot of negative charges around it a lot of the time. And this here is going to be partially positive. Okay, so the hydrogen is going to be partially positive. So if we have something that is totally negative, right? So chlorine has a negative charge. So what happens is that the water goes around chlorine with the hydrogen. Okay. And then they would do the same thing with the sodium, only thing will be the oxygen. So when we say it dissolves, all that's happening is that the water is surrounding those charges, keeping them separated from each other. Right? It's the homework, it's splitting them up. Okay. So because of those partial charges, right, we're able to sit there and surround it. And so that's the thing about water. That's what makes it such a great solvent, because it's able to mess with those charges, right? It also is able to sit there and mess with things that aren't charged as well. You know, long as they have partial charges associated with it, it's cool. It's able to hang out. So we call water bipolar, right? Or two poles, or we say dipolar. Chemistry. Right. So anything that's able to sit there and separate into those charges are going to be able to conduct electricity, right? So any ionic compound or an ionic solution should be able to conduct electricity. So if it completely dissolves, it's going to have a strong signal. So strong acids are going to have a strong signal. Weak acids are going to have a weak signal.
Like battery acid.
Battery acid is a strong acid. And
What's
this
an
is just showing
example
you,
of a weak acid?
what was that?
What would be weak acid?
Citric acid is a weak acid. Acetic acid is a weak acid. So carbon-based acids are weak acids.
Oh, because of the light.
Okay, so this is just showing you what I just showed you earlier, that, you know, the water is basically surrounding based upon the partial charges. And then if we put like copper 2 chloride in solution, right? So here we have a copper 2 chloride. This is the way it is. When it's not, it's all together as a solid. When we put in solution, it dissociates, it ionizes. Okay, so write the dissolving equation for K2SO4 solid. So if I stick it in water, what happens? What am I going to get? I want you to do it without not looking at it. When I want you guys to read, you don't read. But when I don't want you to read, you read. Okay, so what are my ions that I'm getting? Calcium. So plus. Okay. Sulfate. Okay, should there be only one potassium ion? How many should I have? So when they dissociate, can I borrow some people? Yes. No, H2O. So the H2O becomes that aqueous. Okay, can I borrow somebody? Somebody's. Okay, so I'm gonna be the sulfate, right? I'm big enough on sulfate. Okay, your hands. Okay, now we're together initially as a solid, right? Can't hold her. You have to hold me to hold my hand. Okay, so as soon as water comes, I separate. I tuck in the water. But these guys, water, sexy. Ooh, water, you know? So they are gonna separate. They're not gonna react. So in that context, I have two potassiums, and then there's just a sulfate by myself with water, right? So they're going to be acting independently. So that's the reason why we have them as two rather than a subscript. Does that make sense? Because they're independent. They're not combined.
Yeah.
Okay, so let's write the ion present in the solution for calcium nitrate. You don't have to write the whole equation. Just give me the ions that are present. Okay, nitrate's got what charge? Negative. So we're gonna have nitrate with the negative. And what else? And calcium with the plus. We know we're gonna have those two nitrates in there. Okay, that's pretty much ionization. Now we can do this for a whole chemical equation. We'll talk about that on the other day that we come. Wednesday before we start class. I mean, okay. So I'll let you guys go.